Assalamualaikum warahmatullahi wabarakatuh. My name is Asfa bin Azmi and I would like to tell you about applied maximum and minimum problems. Also known as optimization problems are a branch of mathematics that deals with finding the highest, which is maximum, or lowest, which is minimum value of a specific quantity in a given context or situation. These problems involve identifying the optimal solution that maximize or minimize a certain objective while considering various constraints or conditions. Okay, let's move on to users and real life application. For users, which is approximation value and tangent and normal to a curve, and it also for increasing and decreasing fx. For real life application, it is for designing vehicles, predicting the behavior of object in motion, and also for developing control system for robotics.
Assalamualaikum warahmatullahi wabarakatuh. I am Audi binti Zulkafli and I would like to tell you about the application of differentiation. First, we have related rates. Second, maximum and minimum problems. Third is rule theorem and mean value theorem. And lastly is the analysis of function to determine the increase or decrease of concavity. Next, we are moving on to how to solve certain problems. For the first step, we need to find the derivative. Second, we let the derivative equal to 0, f prime x equal to 0, and find the values of the variables. And last step is we need to do the second derivative test. If f double prime x larger than 0, it is a minimum value. If f double prime x smaller than 0, it is a maximum value.
Okay, so let's go to the problem statement. I have provided example of the question related to this topic. So the figure 1 shows a closed rectangular box. The length of the box is twice of its weight. Given the total volume of the box is 600 centimeter cube. So let's go to the question and how to solve it. Okay, for the solving the problem session, let's we go to the first question, which express y in terms of x. So as we know how to calculate the volume, we need to x times with x and times with y to get the total of the volume. So from the equation, we can see that v is equal to 2x times x and times with y is equal to 600 centimeter cube. And we can simplify it to 2x squared y equal to 600 centimeter cube. And we can simplify it to y equal to 600 over 2x squared, and we can divide it and simplify it to y is equal to 300 over x squared. So for the proving the given surface area, which 1800 over x plus 4x squared. So the question is about we need to prove the answer. So we need to provide how to get the answer. Okay, so let's we go to the calculation. Firstly, if you saw the 3D rectangular box, if you split it or open it to 2D or into 2D image, we can see how many sides of the two x and y. So it make you easier to count how many sides of the box has. So it make us easy to count the surface area of the box. So let's go to the calculation, which area is equal to 2x times y plus with 2 and 2x times x plus 2 in the bracket x times y equal to 4xy plus 4x squared plus 2y. equal to 6xy plus 4x square and equal to 6x in bracket 300 over x square, which y we insert from the answer from the first question, close bracket, plus 4x square. And the final answer we can get area is equal to 1800 over x plus with 4x square. Okay, so let's we go to the third question, which find the value of x and y which a is minimum. So firstly we need to apply the first derivative test, which we need to differentiate of the given surface area. So it is equal to minus 1 in bracket 1800x with the power of negative 1 minus 1 close bracket plus with 2 open bracket 4x square minus 1 close bracket. So after we differentiate, we will get minus 1800 over x square plus 8x equal to 0. So actually from this stat, uh, to remove the x square of below the negative 1800, we need to times all of the number with x square in order to remove the x square below the 1800. So that's why the 8x become to 8x with the power of 3. Then we need to proceed that the answer is 1800 plus with 8 with x power of 3 equal to 0. So uh, we need to bring the one of the number besides to replace the 0 and become 8x power of 3 equal to 1800. So we can find the x, which is x is equal to 3 square root 1800 over 8. So we can find the value of x, which is 6.0822 cm. Then we can apply the value of x in the answer of the first question, which is y equal to 300 over in bracket 6.0822 close bracket with the power of 2, and we can get the value of y, which is 8.1096 centimeter. So for the last question, we need to find the minimum surface area. So we just apply the value of x and y in the x and y in the given surface area. Uh, just like for xy, so we insert the value of x and y and we can get the answer. So let's go to the calculation. The area equal to 1800 over 6.0822 plus with 4 open bracket 6.0822 close bracket with the power of 2. So the final answer is 443.9182 centimeter cube. So that's all for the solving the problem of the question.
In summary, we explore apply maximum and minimum problems in the context of optimizing the area of a printed material with given margins. This demonstrates the practical application of calculus in making informed decisions, achieving optimal outcome within constraint. Recommendation: First, investigate and analyze other practical applications of a optimization problem beyond the area of printed materials. Second is familiarize yourself with software tools or programming language that can assist in solving optimization problems. For the last is explore additional optimization problem in different contexts such as resource allocation, cost minimization, or time optimization.